Good evening and welcome to CSU Extension's webinar on Japanese beetles. Tonight we'll be exploring a very tricky insect. Japanese beetles have exploded in many communities in eastern Colorado, as well as a garden insect from Pueblo to Fort Collins. It's an unusually difficult insect to understand and manage. So thankfully we have Dr. Whitney Cranshaw with us tonight. He'll be discussing the basics of Japanese beetle situation in Colorado and some ideas for management. With us tonight, we also have colleagues in CSU Extension. We have John Mergel in Douglas County, who's a horticulturalist, and Carol O'Mara in Boulder County, who's an entomologist and horticulturalist. And then we also will be joined later on by a new faculty member at CSU, Ada Strapanecki, and she will be also answering questions behind the scenes. So here's what to expect tonight. Dr. Cranshaw has a 2-hour presentation and we'll try to save some room at the end for questions. The Q&A box will be open and we encourage you to use that if you have clarifications on anything that's being said and being taught as we go. If you have general questions or things you'd like to know, we're going to ask that you save those questions for later in the talk because Dr. Cranshaw is going to anticipate many of your questions, and so he will likely answer your questions as we go through the curriculum. So try to save a lot of those difficult questions for the end. But if you have points of clarification along the way, feel free to put those in the Q&A. All right, without further ado, I will pass things over to Dr. Cranshaw, and we'll get started.
Okay.
You should be able to share. All right, there we go. Perfect.
Okay. So can I get started?
Yes, go for it.
Yeah, all right. So I'm not going to take 2 hours talking here, but this may be about a little more than an hour or so, but I hope we can have some robust discussion afterwards, because this is, I think, by far the most complicated insect issue that I've ever had to deal with in Colorado because of several interesting angles. And it is a emerging issue in many areas in eastern Colorado right now. So just a little bit background, this is an insect that is native to Japan. It was introduced in the United States a little more than a century ago into New Jersey. It came in on nursery stock. And then over the next 90 years, it did spread, but during the first 90 years or so of its occurrence in North America, it pretty much was only found east of the Mississippi River. Now, in the 1990s, there were occasional interceptions of this insect being brought into Colorado, but they never established. We did not get reproducing populations really until the early 2000s anywhere in Colorado. Now, the situation has changed quite a bit. And in terms of exploding, the point I like to make in terms of how this has increased over time has to do with an interesting snapshot in time of what the Japanese beetle was. Back in 2008, there was a massive trapping program done in large part with extension people involved, as well as Department of Agriculture and some other agencies. But basically every little dot in this map in Denver was a trap that was put out in 2008. And I don't know if you can see the legend, but the light colors mean they got few, if any, beetles in one of these Japanese beetle traps. If you're not aware of what they look like, I'll show those to you, but it's a very effective trap for catching them. But the light colors are all essentially, under 20 per year. In the whole year, they got less than 20 per year. And I point out there's a little arrow I put in here because a few years ago, started putting a trap, the cooperator down there in South Denver had a trap. And in that area where there was under 20 in a summer, back in 2018, 2019, she was getting over 1,000 Japanese beetles in a trap every day. Not, that would have been a dark red dot just in one day. So this thing has exploded. It's particularly bad right now in parts of Denver and western Arapahoe County. In Boulder is a separate outbreak area, in Pueblo, but it's spreading. We're seeing it in Fort Collins. People are just starting to really notice it the last year or two. I'd say we're at the stage in Fort Collins where this was maybe in 2008, that part of Denver, but we're going to get hammered pretty soon here. There's no really good map of good mapping of what's been done, but in general, the Department of Agriculture, if you go to the Colorado Department of Agriculture website on Japanese beetle, they have a general map of where they have detected Japanese beetle and at what density. And as you can see, there are some areas in red, and those are the areas that I've mentioned before: the Pueblo area, the Denver and western Arapahoe County, and parts of Boulder. And then there's other areas where there's low numbers. We have moderate Japanese beetle up in Larimer County, and again, it's increasing there. But it's pretty widespread, and now that it is well established in Colorado, this is an insect that is going to spread, I think, a lot more easily. The main way I think it'll probably spread within the state from this point on is it can travel in vehicles. I mean, you have your windows open, this beetle gets in cars, and we're moving it all around. But presently it is not known, although it once was, west of the Continental Divide in our state. Now, part of the reason this insect is so complicated to talk about is that it is really two different kinds of insects, I think, and because it damages plants in two different ways, depending on what life stage we're talking about. Most insects, they're damaging in one stage. A caterpillar is damaging, but not the moth. But in this insect, we have it damaging both as an adult and as a larva. When it's an adult, that's what most people notice. That's a beetle that's on leaves, it's on flowers, and it feeds on a lot of plants, and that's what attracts most attention. But every Japanese beetle adult was once a white grub, a kind of insect that lives in the soil and feeds on the roots of plants, particularly grasses. And Japanese beetle is probably the most important of many white grubs that are the most important of all the turfgrass insects in North America. I'm going to talk about the larval stage first, although again, most of what people think about with this insect is the adult that's chewing on their leaves and flowers. So if you're not aware of what a white grub is, because we really have not had big white grub problems in much of the state up until now, and we'll see a lot more of them. White grubs develop in the soil, and the ones that are damaging to the plants are ones that feed on the roots of living plants, particularly grasses. Japanese beetle and the turfgrass damaging grubs feed primarily on grasses. So they will occur underneath the soil or underneath the sod, underneath the layer, chewing and pruning the roots. So the picture in the lower right shows an area of turfgrass that has been cut by the larvae. You can kind of peel it back. And obviously the effects of white grub damage are going to be manifest in drought stress primarily, because the roots aren't there, so the plants are under more drought stress. One thing that people will often notice first, well, depending on where you live, if you've got critters nearby, is all of a sudden there'll be skunks or raccoons digging in a lawn. If you see skunks or raccoons digging up a lawn area, they're going for some insect, and there's no other insect really that is ever abundant enough and big enough to make it worth their while. So if you see nighttime digging by a skunk or raccoon, think white grubs are there. Now, we have had always some kinds of grubs in turfgrass in some areas of the state. So the adult stages of some of the white grubs that occur in Colorado turfgrass are shown here. The Japanese beetle is in the far left, but the others have been here for quite a while. The Japanese beetle is the new one. And if you live in areas in like the Tri-Rivers counties or Pueblo or out on the Eastern Platte in the counties in Eastern Colorado, you'll have perhaps seen white grubs in your lawn that are a native species, the Western masked chafer. People never really notice the adults much because they don't hurt plants, but the larvae feed on the soil, feed in the on the roots of turf grass. So this is the size of a full-grown one of those found in Fort Collins. They're quite rare in Fort Collins, a little more common as we get a little to the east of here, but we do find them here occasionally. So that's one that we've always had. That's not a new one, but now Japanese beetles coming in and much more common will become the white grub. And then there's another kind of white grub that has always been in Colorado that occasionally damages turf grass, and that is larva of a fairly large beetle called a May-June beetle. And there's several species in the genus Phylophaga that do this. And these are ones that are quite big. The larvae get quite big, but they also, if you see them in your lawn, you'll also see more of a range in size because the May-June beetles that are native have a life cycle that probably takes 3 years to complete. So you'll see grubs that are nearly full grown and ones that have got another year or two to grow. So if you ever see a white grub situation in a lawn that's got a lot of variability, that's probably one of the May-June beetles. These have mostly been a problem, again, in the Eastern Plains historically, not in Western Colorado. I have seen them as close as Windsor, but I've never seen them in Fort Collins. And then there is kind of an unusual one that is occasionally found in lawns. It's our largest grub and one of our largest beetles, the 10-line June beetle. And if you see a really big grub in a lawn, that's probably that one. Not too important, but pretty impressive if you ever see it. And the adults, by the way, if you pick them up, they'll often hiss. Scares cats, I know. But anyway, that's an impressive beetle. Now, the whole situation about how we manage white grubs in lawns, we've had information on this for a long time. Japanese beetle is just one of the white grubs, but there is a fact sheet you should be aware of on white grubs and a related kind of insect that damages turf grass called the billbug. These white grubs of various kinds do all look, pretty much the same. A white grub is going to have this kind of C-shaped body, going to have a very distinctive head, doesn't have any legs on the abdomen, but has prominent legs on the thorax, 3 pair. And they range in size depending on the species, but there's actually a way you can tell what grub you have if you really get into this, and that is checking the rostral pattern. And checking the rostral pattern means you look at the butt end of a white grub, and there is various slits and hairs that can be used to identify what kind of grub you have. Now, this is not anything I'm recommending that you go out and do, but if you want to learn what kind of grub you have, there is this definition, there's this ability to identify it through the rostral pattern. So that's in that fact sheet on Colorado white grubs and billbugs that I just referenced. Before I leave white grubs, I also have to mention there is one very common grub that people see, probably the most common white grub that people see, has nothing to do with plant injury. It is a grub that you get in compost. You get it in decaying animal manure or other. It's a decomposer species. The adult is called the bumbleflower beetle, but you might find it in again, compost or horse manure or all sorts of other places. A native species, not a plant damaging one. Most white grubs, and there are a lot more than we find damaging turf grass, the great majority feed on decomposing organic matter and are not plant pests. And that's the big one, bumbleflower beetle. So you might want to sometime read up on that one. All right, but let's just talk about managing Japanese beetle in the larval stage. So in the larval stage, what we're talking about would be this insect damaging our lawns. So the white grub is going to be feeding in the root zone. It's going to be pruning the roots. And if you have a sufficient numbers of that, that's going to cause stress, drought stress, and in some cases, it can lead to death of the turf. So there are various kinds of things we could do to manage this. There are some cultural controls, there's some biological controls, there's some chemical controls that can work on Japanese beetle larvae. These are all kind of summarized in the general fact sheet we have on Japanese beetle. There are other resources that I'm going to show you on this subject, but all this is generally covered in this publication here. So if we're talking about cultural controls for Japanese beetle larvae, one of the things could be growing a turf area in a way that better tolerates damage. So the damage they cause is pruning roots. If you have more roots, if you have a more vigorous root system, then the effects of the grubs are going to be largely mitigated. So how do you promote root growth? That would be done by watering that promoted deep root growth. Another simple way to prevent this kind of injury or to mitigate this kind of injury would be mowing height. I think you probably had this in the turf grass talks, how to grow turf grass, but a little bit higher mowing height does result in a greater mass of roots. And if you have a greater mass of roots, then the grubs may not be producing any kind of visible or significant kind of injury. Another thing that it would be a cultural control is soil drying. Now, obviously, turf grass needs water to grow, but if you could cut it back a little bit, that at certain key points, that can very dramatically reduce survival of Japanese beetle larvae. So a little bit about Japanese beetle before we get into this. So in terms of how it appears during the season, it is an insect that has a 1-year life cycle. So every year, all the stages are completed. You're going to start seeing the adults coming out often in the middle, more often the late part of June, and they lay almost all their eggs in the soil during this very early part. And then later they will feed throughout the summer, then go down below the frost line, and then resume feeding in the spring. Most damage is done in August, September. So like any other white grubs that damage turf grass, the adults burrow into the soil. The eggs are only going to be laid in areas that are suitably moist. So if you have little dry areas, the beetles won't lay their eggs there if it's dry during the time that they're laying eggs. And if it dries after they have laid eggs, that will kill them. The Japanese beetle eggs are very susceptible to drying out after they have been laid. And that is one of the things that regulates populations of Japanese beetle in other parts of the country where we have rainfall or not, and that's how you get all your moisture. And if it's very wet throughout the summer, the soil stays wet and the eggs survive well. And if it is a droughty summer, then the eggs survive poorly, and the numbers the next year of adults are lower. Also, the very first stage larva. So the egg will hatch and will produce a young, tiny little grub, and that will feed for a while and molt and get bigger, and feed for a while, molt and get bigger. And these stages are, the larval stages are largely completed in the first year. The third stage finishes up the next spring and then pupates. Anyway, that first stage larva, as well as that egg, is very susceptible to drying. So if it has been laid and it's hatched and it's starting to feed and the soil dries a little bit, there'll be a lot of larval mortality. So if it's possible to cut back a little bit on the watering during this period when they are very susceptible, that can have a negative impact on their numbers, which is a positive for helping manage this. Now, later in the season, after they've gotten over that first stage when they're quite susceptible to drying, that doesn't help. And so maybe watering later in the year, if you have had injury, might be something to consider, just to allow the roots to regrow from the injury. So this is a different kind of aspect. A little bit of watering later to help plant recovery has nothing to do with reducing numbers of the beetles, but it has an effect on helping the plants tolerate and recover from the damage that was done by the beetle larvae, the white grubs. Now, there are various kinds of treatments for white grubs, including the Japanese beetle. There are some standard synthetic insecticides, and there are some biological controls. Now, the standard insecticides, there's 4 active ingredients that you can find in our recommendations that do control them well, but really there's only 2 that are widely available for homeowners, as well as used in turf grass. One is the insecticide imidacloprid, and the other is got the kind of tongue twister name, chlorantraniliprole. And I'll try to talk about using the trade names of this. So Scott's Grub X would be chlorantraniliprole or Celiprin. And then there are some biocontrols that'll come out after this. But let's talk about the big 2 insecticides we have and how they would be used for white grub control, including Japanese beetle. So imidacloprid is something you could find at a retail store as a high yield insect and grub control product, high yield grub control 2, one of the Bayer advanced season products, season-long grub control. It is a neonicotinoid insecticide that moves systemically in the plant. As such, it can have hazard to bees if they're exposed through nectar and pollen. But again, we're talking about turf grass here. It can provide control for a month or 2. It's fairly slow moving into the soil and into plants. So the optimal time for using this is during the early period of egg hatch, typically late June through mid-July. Is when we would be using this product, because it'll last for a month or 2, and you want to put it in at just as they're starting to lay eggs, and it will be able to control the young larvae as they hatch from those eggs. So don't put it on too early, and don't put it on too late, but sometime in late June is the best time for this product. So early period of egg hatch, typically late June through mid-July. Now, this brings up an issue with systemic insecticides and pollinators, something I'm sure has been discussed in some other topics. Should there be a concern about their use on turf grass? Well, turf grass is grass, and pollinators usually don't visit grasses, but there can be some situations in a lawn where there is a risk. And that would be if you have flowering plants mixed with your turf grass, as I do in my yard. I've got violets, and I've got clover, and I've got dandelions, and I've got lots of bees that visit my lawn. So if you have flowering plants in a lawn, yes, you do have a potential route of exposure of a systemic insecticide to pollinators that would then visit the flowers and acquire the insecticide through the nectar, or perhaps the pollen, usually the nectar. How do we mitigate the risk? Well, one thing that has a huge impact, can have a huge impact, is to mow a lawn before using an insecticide. That can largely mitigate the risk from a systemic insecticide. Even something like imidacloprid or clothianidin greatly reduces it if you mow beforehand, because most of the exposure will be shortly after that application. So if you do have flowers in a lawn and you are using an insecticide, always mow it before you do anything about that. Then there's a second product, this chlorantraniliprole. a fairly new product. It goes on the trade names of Celiprin in the tree care, lawn care market and tree care market. And GrubX is probably the retail formulation you're most likely to be able to find at a store. This is a new class, new kind of insecticide, and it has extremely low hazard to bees. And I'll talk a little bit more about this. This chlorantraniliprole is an insecticide in a new class of insecticides that has been inspired from a natural product. The natural product that this group of insecticides is based on is something that probably few people have heard of before. It's called Ryannia. It's an old product that used to be used in organic production. It isn't now; it's too expensive. But Ryannia is a natural product. Used to be used in particular in orchards for codling moth. And the active ingredient in Ryannia is ryanodine. And these are the chemicals that have been looked at to make this new class of insecticides that we're talking about here. So the anthranilic diamides, based on these Ryannia compounds, the ryanodines, they have a little bit of systemic activity in plants, but not a lot. But one of the things that I think is extremely desirable about this is these have very low toxicity to mammals. When Celiprin came out, it came out as a Category 4 insecticide in terms of hazard to mammals, and I didn't know there was a Category 4. Category 1 is it will have a danger poison on the label. Category 2 will have warning on the label. Category 3 has caution on the label. Category 4, I mean, soaps have got caution or warning on it. Category 4 has nothing. It says wear socks while you're applying it. So in terms of being a very low hazard to mammals product, I think that's a desirable thing. It is also has extremely low hazard to bees. And it will get to it does not even have a warning about bees. It's about the only standard insecticide, synthetic insecticide, that has no label restrictions regarding pollinators because it is not hazardous to bees. Optimal time for this would be, again, the early period of egg laying, egg hatch, typically mid to late June through mid-July. This will last at least a couple of months. It's a highly effective white grub product, but I think has some desirable aspects. Even though it is a synthetic insecticide, it is naturally inspired and has some nice biological characters. But we also have biological controls. If you don't want to use a synthetic product, there are biological control options for larvae of Japanese beetle. And one of them would be what we call entomopathogenic nematodes or predator nematodes or insect parasitic nematodes. And these have been around a long time. We've been recommending these for 35 years. So these entomopathogenic nematodes are a kind of nematode that develops within insects. They're one of the natural controls that you find affecting insects, and they are able to be cheaply produced and can be sold for control of various kinds of insects. And people have been using these, again, for 35, 40 years. They go under various trade names. Again, insect parasitic nematodes, beneficial nematodes, predator nematodes. There are, of course, nematodes that have other aspects in terms of how they will develop. Some nematodes damage plants, for instance, but these develop within insects. How these would be used is you would purchase them, you would mix them, they would come on a sponge or some other medium that you would mix with water, and then you could spray it onto a lawn area and wash it into the soil, and they will then seek out and kill white grubs. So nematodes, these insect parasitic nematodes, these entomopathogenic nematodes, work to kill insects by entering the insect in some way. Now, some of the nematodes we have enter insects through natural openings. And what would be the natural opening, in a white grub? It would be their mouth, it would be the anus, or it would be the spiracles, little holes in the side of their body. Now, the way white grubs happen to be built, nematodes usually can't get in through these ways, these natural openings. But there are some nematodes, and I want to make this point right here. I've got this Heterorhabditis genus of nematodes. Those ones are capable of going right through the body wall of an insect. So those, if you're getting nematodes to control white grubs, you want to get ones that are in the genus Heterorhabditis. Very commonly sold will all be nematodes in the genus Steinernema. These are great for caterpillars, like a cutworm in a lawn, but they are terrible for control of white grubs. So you need nematodes in the genus Heterorhabditis. There are several companies that will supply these for you, but you just make sure you get one that kills grubs. One genus kills grubs because it can go right through their body wall, and the other can't do that, so they're not very effective. Entomopathogenic nematodes, when they do get into the body of an insect, how they kill the insect is they actually then introduce a bacterium that they carry in their digestive tract. They introduce this bacterium that then grows in the blood of the insect. So all the entomopathogenic nematodes, all these insect parasitic nematodes, have with them a kind of bacterium that actually kills the insect. Then the bacteria decompose the insects, and the nematodes actually eat the bacteria and the decomposed tissues of the insect. So this is why they're called entomopathogenic. They are nematodes that introduce a pathogen that kills an insect. And the kind of bacterium that are introduced by different nematodes will have different colors. And the Heterorhabditis one, the one that kills white grubs, it makes it kind of a brick red color. So here you can see colors, the color of a grub that's been successfully infected by one of these Heterorhabditis nematodes. More recently, we have another product. So this is in the last 3 years. It is a strain of a bacterium called Bacillus thuringiensis, or BT. Many of you are aware of BT or have heard of BT. Bacillus thuringiensis is a species of bacterium that has been mined for being able to be used to control insects for 70 years now, sometimes since the 1950s. But there's different strains of BT, and historically the oldest ones that were used just killed caterpillars. We were talking caterpillars or moths, they turn a moth or butterfly. We're talking about something that kills beetle larvae, and a new strain came out called Glary, or BTG, and that is effective against white grubs. So you might see this product, BTG, Bacillus thuringiensis Glary strain, under the trade name GrubGone. So that is another alternative. You could use the insect parasitic nematodes, or you could use the BT Glary if you didn't want to use the Scotch Grub X or one of the other synthetic insecticides. So there's some very good larval treatments for white grubs out there. But again, GrubGone is the new one. I don't. Anyway, it works okay. I'm going to come back to this insecticide later because in a different formulation, I think we have a better niche for it to control adults. So that's what I'm going to get to in just a bit now. One last thing in terms of treatments that people have been using for Japanese beetle you hear about is something called milky spore. Milky spore is another kind of bacterium, and it is a bacterium that is applied to a soil area, and if the grubs feed on it and get successfully infected, they will get a milky color to their body. I'm not sure how well you can see, but on this grub on the left, there's a broken leg and there's a little clear drop of blood, and it's a little milky drop there. This is not used to kill grubs immediately. It is a type of biological control that is used to be introduced into a site and will have long-term effects of some kind in suppressing it. You don't get control the year you apply it. You might get some control the subsequent year. However, milky spore for Japanese beetle, I think, is among the most overrated of all the kinds of biological controls against any insect I've ever heard of. It may help produce some reduction in numbers of larvae surviving to adulthood. However, typically, people find that less than 1 or 2% of the population is ever affected at all by this. So this is not a panacea. This will help give us a little bit of incremental reduction in Japanese beetle, and I'll return to that later, but this is not something you use to get rid of Japanese beetle grubs. Doesn't work that way anywhere. I mean, it's in many states, they don't even recommend it anymore. It's been so underwhelming in terms of performance. So you'll hear about it, but in my estimation, this is way overrated. Now, there are a number of things that are going to help you to guide in terms of keeping all this stuff straight. In addition to the fact sheets that we have that I've been referring to, I'm going to show you, we have a cheat sheet summary of all the insecticides that can be used on Japanese beetle white grubs. It's going to be found in a subsection of a website that I'll refer to at the very end of this talk. But this publication here, it's, I think, 3 pages, and it just goes through all the different active ingredients, their trade names, retail or commercial, and comments in terms of how to use it, and warning issues in terms of certain environmental hazards and how to avoid those. And since I don't get to talk about this much anymore, I just want to throw in one white grub treatment blast from the past. One of the very first things that I ever worked on when I was here in Colorado were grubs, and particularly the big grubs that we get down in the Arkansas Valley. And at that time, we're talking now in the 80s, there were a few products that we used to control white grubs, but if you could get 50% control, particularly as they got big, you were doing great. Products we have now are much more effective, including our biological controls, than existed 35 years ago. Plus, they're much safer. Anyway, one winter, I was going through my garden catalogs, and I happened to see this product called lawn aerator sandals, and I was a little, having a little trouble with the grubs and a little frustrated. So I said, why don't maybe I'll try that. The spikes of death. So we put that in trials back in the 90s. There's a former student of mine, Rick Zimmerman, working on one plot. There's my father in another plot in Western Colorado. And basically, I just put them in the middle of the plot. I'd carry them over on my back, and then they'd stomp around in a little area. And some areas would have, say, diazinon on it, and some they'd be stomped on. And we got control comparable to the existing insecticides of the time. So anyway, spikes of death, get a little exercise while you're doing it. Just don't walk through the irrigation lines with these. So here it is after a nice hard day at work. That's a pose picture. Anyway, I was very happy to see this several years ago appear in a cartoon in the Denver Post, because this did get some publicity. So anyway, more than one way to skewer a grub here. Okay, however, big question comes up is, will control of grubs, the larvae in a lawn, affect the number of adults in a yard? And again, most people, what they're worrying about are beetles chewing on their roses. they may not notice damage to their lawn. They're feeding in the lawn, but they may not be damaging it. And unfortunately, the answer is no. There is almost zero correlation between how well you control the grubs in your yard and how many beetles you are going to have feeding on the leaves and flowers. And that's because Japanese beetles are so mobile. The Japanese beetles in your yard are coming from blocks and blocks away. They're not coming from your yard. You're the ones from your yard are spending summer halfway across town. This is a highly mobile insect. And when you have a highly mobile insect, controlling the larvae does not have a big effect. We have some very mobile insects. Flea beetles will blow hundreds of miles. The potato tomato psyllid comes up from Texas every year. Japanese beetle is a highly mobile insect. So a lot of people want to control Japanese beetles on their roses, and they spend a lot of time controlling the larval stage in the lawns, and it's going to help a little, maybe, but not much. This insect moves around too much. If you have Japanese beetles as a problem in your lawns, definitely do something about it. But don't expect a lot of benefit your treating of your lawn in terms of how many beetles you're going to get. I'm sorry, that's the way it is. But a lot of people spend too much time worrying about the larvae when really the problem is the adults, and those two things are not linked in your yard because of the high mobility. So let's talk about the adults. The adult beetles are going to be insects that feed variously on flowers or leaves of ornamental plants, as well as garden vegetables and herbs. And the damage is very often what we call skeletonizing. If it's feeding on leaves, Japanese beetle adults will produce a kind of injury that not too many other insects do, and that is skeletonize the leaves, meaning they will feed on the leaf surface in a way that avoids the main veins and also usually avoids the opposite surface of the leaf. So essentially, you're left with a skeleton of the leaf. They don't chew the whole leaf; they kind of pick between the veins, and that gives the plants a kind of a lacy appearance that is quite distinctive. So there's very few insects that produce skeletonizing in this state, and Japanese beetle adults are going to be the #1 insect that does it in many areas. Flowers are often a favored part that's targeted by adult Japanese beetles too. So here we see them on roses, notorious on roses, and there's silver lace vine on the right. And this brings up a huge issue with Japanese beetle. There is an overlap of adult feeding on a plant part that is simultaneously being visited by pollinating insects in many cases. I mean, I can't think of a bigger potential risk application of a pesticide than that we have than to try to kill Japanese beetles on flowers. I mean, they're chewing on a leaf chewing on a flower that is being visited by a honeybee or a bumblebee. So there is a special concern with how to deal with Japanese beetle if they're feeding on a flower that's being used by a pollinator. Our options are really reduced because we cannot use most insecticides on a plant in bloom that's being visited by pollinators. Very few things allow this. Now, this is a problem because when we look at some of the plants that Japanese beetle really likes, I'd say the uber hosts, the ones that they really like, are certain roses, certain lindens, Virginia creeper, silver lace. These little asterisks I put behind each of those, 2 asterisks means that those plants are in flower most of the time when they're feeding on the plant. Linden, they feed on the plant when it's in flower, and then the flowers go past, and same with Virginia creeper. But there is a lot of overlap of flowering of these main hosts when the Japanese beetles are in it, as well as some of the ornamentals, hollyhock, gaura, rosa sharon. Oh, I should have put double dots next to canna lily. These are plants in flower. And how do you get rid of Japanese beetle adults without killing the pollinators? So we'll talk about that. This insect does also go into some food crops, particularly beans, basil, raspberry, grape. There are variations in host plant susceptibility and in cultivar susceptibility, and I hope we can get more information on this. But just to show you how this could work, there is a wonderful garden, rose garden in Littleton, in Stern Park, the War Memorial Garden in Littleton. And this has over 160 different kinds of roses growing and has been a fantastic area for us to look at what roses are damaged and what roses aren't, as well as whether they're visited by pollinators or not. So basically what has been done here, and I can provide the information on this, it's all summarized now, is observations were made over several years. The first year we did 7 observations during the season, and each variety of rose was ranked on a 0 to 3 scale with no damage to heavy damage. And again, we did it multiple times. We also looked at whether there were bees visiting the flowers. Again, on a 0 to 3 scale is what we used. No visitation to high visitation. And what we see is among these 150, 160 species of roses or cultivars of roses, there were some that we never saw Japanese beetles on. And these would be some that had no Japanese beetle damage at all. And we would have some cultivars on which no bees were ever noted. They didn't visit. Certain kinds of roses are bred in ways that they become unattractive to bees, or had very few bees. So if they have no bees visiting, then the insecticide options might be increased. So basically, the way I think we should look at some of these, and rose would be an example, is how badly damaged are they by bees or by Japanese beetle, and how often or well used they are by pollinating insects, in particular bees. And basically, you can make a little matrix like this, and in the upper right would be ones that we saw a lot of bees on, and we saw a lot of Japanese beetle damage. And those are the kinds of cultivars that in a post-Japanese beetle world are going to be difficult to control Japanese beetle on, because we'll have very few insecticide options and a risk to pollinators when we use it. On the other hand, we can see there are some cultivars that Japanese beetle doesn't damage in the first place, and these would be ones that we could shift to. Or there are cultivars there on the left where bees do not visit. So if bees are not visiting it, then the potential risk to pollinators is largely goes away. Anyway, these kind of observations need to be made for a lot more plants, and perhaps through the Master Gardener program, we can collectively get these kinds of observations to help guide us in cultivar selections here. But there are some, again, that are heavily damaged by Japanese beetle and visited a lot by pollinators. And these are going to be the ones that are just going to be too difficult to grow in the future. I hate to say it, until Japanese beetle goes away, which I wouldn't count on that. Anyway, so I do think what we should do, one of the things we should do about Japanese beetles is try to systematically categorize all rose cultivars for susceptibility to Japanese beetles and their use for pollinating bees. And this has been started, and we need to continue that. We also need to do this for other kinds of plants that Japanese beetle is affecting here in our state. Totally changing the subject a little bit. I just want to put this in somewhere. Another plant that Japanese beetles will feed on, and there's a lot of plants that will feed on. But where there's an interesting angle that you may hear about is geraniums, zonal geraniums. Japanese beetles, if they feed on the flowers, will become paralyzed, and they will drop to the ground, and often they will not recover. So they often will recover in a lab, but outdoors, exposed to the sun, they rarely do. The toxin is present in the flowers, not the leaves. I don't know if there's anything we can use this in a way to control Japanese beetle, but it is something that comes up. Every once in a while, people will hear about it and say, "Oh my gosh, let's plant lots of geraniums." Well, they'd far rather be in your roses than in your geraniums. So it's not a highly susceptible plant, but they will feed on it, and you might notice that. So something to watch for next summer. So what do we do about Japanese beetle adult control? So there's some physical and cultural controls, some traps, hand picking, and there's some chemical controls, including one that's a biocontrol. So hand picking. There are few insects that I think are easier to hand pick than our Japanese beetles. You can just knock them into a jar with maybe some soapy water to kill them. In particular, they're very easy to do when it gets cool. When it gets hot in the day, they'll often fly around. But if it's cool, late in the day, early in the day, very easy to hand pick. And I tell people that my first bug job, was picking Japanese beetles off my dad's roses, and he would give me one penny for 10 Japanese beetles that I collected as a kid, and I made good money. They're so easy to collect. Now, what are the primary benefits from hand picking? Obviously, you're removing some of the beetles, but what you're also doing is you're preventing wounding by the beetles that remain, because you've removed them. And the feeding wounds made by Japanese beetles produce volatiles that are attractive to more Japanese beetles. So by reducing the number of Japanese beetles, you are reducing the number of wound volatiles coming off a plant, and that can have a impact in terms of reducing the numbers of beetles after that point. It can be particularly effective on foliage, if that's where the issue is. Sometimes flowers, it doesn't affect it as much because flowers may produce lots of volatiles that are so attractive on their own, whether or not they're wounded. But there has been some work done with hand picking, and it can reduce the numbers of insects over time. Is there a better time to hand pick than others? Well, this study here indicated that probably evening might be a little better than first thing in the morning. Not a lot, but a little bit better. But again, when they're cool and no longer moving about, that would be a time they're very easy to pick, but it might have a little bit more effect if you did it at the end of the day rather than the beginning of the day. Now, these traps. Japanese beetles have a trap that is extraordinarily effective for capturing Japanese beetles. And it is some variation on the design you see here. It's going to be a baffle at the top leading into a cone, and often the top is yellow. Doesn't need to be. There is an attractant put at the top of the trap. In the picture on the left here, that little cap there has a floral attractant, a 3-part blend that is floral based, that's extremely attractive to Japanese beetles. And they will fly to the trap, they will hit the veins of the trap, they will then funnel down into a collecting container or bag. And these, you can catch a lot of beetles. Japanese beetle traps are minimally useful, however, at best for control of existing Japanese beetle infestations. And this is another difficult thing to talk about with this whole thing. I can't think of another trap for any insect where you get so many insects in the trap. I mean, it feels great. You get hundreds. I got to be doing something. However, this has been shown repeatedly to have minimal impact on the number of beetles that are damaging your shrubs. And the reason is the traps bring in at least as many beetles, more beetles into the area than get trapped out by your trap. So in many cases, you can actually have more damage to adjacent plants or nearby plants if you have a trap. I mean, you still have a lot of beetles. You'll think you're doing something great. It's not. It's great at catching beetles. It's not great at controlling the problem the beetles produce. So this isn't a great video, but here's a little video showing a trap at in somebody's backyard where they put it on a bucket because they were getting so many. I mean these are filled. That's Japanese beetles. By the way, think if you got chickens, so you might want to, you could hitch one of these up and then maybe make a little sock so they would fall onto the ground. Chickens do like them. And you can get a lot of Japanese beetles in a trap. We've had people trapping them, and it's so difficult to count that we just do it by volume. And if you ever want to know, there's about 836 Japanese beetles in a level cup. So regarding these traps for Japanese beetles, if you insist on having a Japanese beetle trap, do not place them anywhere near, at least 30 feet away from any plant on which Japanese beetles feed. I mean, put them on an evergreen or something if you want. Avoid putting them in a site where they might be bringing in long distances. Say you live at the edge of a green belt and you put them at the edge of your yard, they'll all be moving in from that green belt where they're developing on the turf and moving into your yard. And if you really insist on using it, I mean, getting a Japanese beetle trap, preferably give the trap to your neighbor. Put it in your neighbor's yard. Your trap in your neighbor's yard will give you more benefit than your trap in your yard. Anyway, okay, then getting into insecticides. There are several insecticides that can be effective for control of Japanese beetles, adults. By effective, I mean they can kill them and they can kill them for several days. But even the most effective insecticides for Japanese beetles will rarely work for more than a week. The residues wear out, new beetles come in. These are highly mobile. So good control would be being able to control them for a week. And there are some insecticides that can produce this pretty good control, mostly pyrethroids like permethrin or cyfluthrin, and also that chlorantraniliprole. However, as we brought up earlier, we have this problem with Japanese beetle on plants where Japanese beetle is damaging the flowers, and those flowers are concurrently being visited by pollinators. When we have that situation, almost none of the insecticides that are used for Japanese beetle can be used. All pyrethroids, carbaryl, imidacloprid, these, you can't use them. Those are plants in bloom. You'll have residues that will kill the pollinators the next day. I put a yellow line through something called acetamiprid. That could be used if it was applied at dusk, because that has a short persistence in terms of killing pollinators and not very risky to them. But that's a hard product to find. And then there's chlorantraniliprole, but that is only sold as a celiprin, and that's only sold in a formulation for tree care companies. There's no homeowner formulation of that, only for that active ingredient for white grubs. But there is, again, there is a acetamiprid that does allow you to use it after dusk when the bees are not visiting. And celiprin has no warning. Again, that's the one synthetic insecticide where there's no warning for bee hazard, because it is that safe to pollinators. However, the option for homeowners that is developed is this BT product that I mentioned before, a Glary strain, new product. I mentioned a formulation sold as Grub Gone for grubs, but where I think its real niche is adult control. And there are two products I can see. One, a beetle juice, I got to go online, but I see Beetle Gone in the nurseries now. And these are a material that is mixed with water, and they're sprayed on the plants. It is a BT that works just on certain kinds of beetles. It works like all BT products do, though. All BT products are a soil bacterium that contain a toxic protein, and if that toxic protein if the insect is susceptible to that toxin, after it ingests it, it will destroy essentially its midgut. It will keep it from feeding, and ultimately will kill it. And there have been different strains of BT we've had for a long time. In one nursery, I could find 4 products that contained 4 different kinds of BT. But the new one is this Beetle Gone or beetle juice, and it has to be eaten. You spray the leaves, it has to be eaten. The toxic crystal, then if the insect is susceptible to the toxin of that BT, it will break down their gut. They stop feeding, and then usually die a few days later from the effects of starvation and the destruction of their gut. So what we have now is Beetle Gone in commercial ag markets, but also now on the nursery shelves, and beetle juice in the gardener market, mostly in mail order. And I've used these. I was very impressed. So beetle juice treated leaves versus water checks, and it provided good reduction in feeding by Japanese beetle, even for 4 or 5 days. Most BT products don't last for 3, 4, 5 days. This did. It provided reduction in feeding almost immediately. What it didn't do is cause the insects to die quickly. It did, again, persist for several days, at least 4 or 5 days. There are no bee hazard warnings for the BT Galeria. This is a product that can be applied to plants in bloom when bees are visiting. That is pretty much all we have. But if you do make an application of a BT product, after the application, are they dead? No, they're probably not. They're still in the plant. But are they still feeding? Probably not. So you have to understand that when you're using a BT product. It is working in a different way. It paralyzes their gut. It doesn't kill them immediately, but it does stop feeding. So again, lots of insecticide options for control of adult Japanese beetles, and this would be the cheat sheet on that as well. So couple last points that I want to make. These Japanese beetle traps are excellent, as I said, for detecting the presence of an insect in an area. The snapshot kind of study that was done back in 2008, again, largely with extension involvement and master gardeners, I think is a wonderful snapshot in time, and I think it would benefit if we tried to do it again. Right now we have this map that the Department of Agriculture puts out that's really general in terms of where they are, but what I think we need to do better is kind of track a little bit more, particularly in the areas where it's just developing, maybe Colorado Springs and Greeley, Fort Collins, and the like, Longmont, and watch how this insect is developing, see how bad it is now, and then come back maybe 5, 10 years and see how it changes. So I think maybe something to talk about would be maybe doing some surveys and maybe getting master gardeners involved in that to do some annual surveys in certain areas of eastern Colorado particularly where it's just becoming established, to get a snapshot of what's happening at this point in time so we can see how it changes over the next decade. Anyway, the last thing I want to talk about is the issue of introducing natural enemies of Japanese beetle. there are things that are feeding and developing on Japanese beetle in other parts of the United States, organisms that have been introduced in the United States and help suppress Japanese beetle. When Japanese beetle got to Colorado, the things that attack it elsewhere did not move here to Colorado. Should we consider trying to introduce for permanent establishments certain natural enemies of Japanese beetle into Colorado? And I would say yes. I think this is something that should be done and is being done. Now, what we're talking about here is introducing an insect, bringing it from another state. This is a kind of thing that has to be done with permission. Government. It's a government-run operation. It has to be done with permitting. You cannot do it yourself. It's done by state or federal agencies, and we have been doing that here in Colorado with that kind of activity. So there are some natural enemies of Japanese beetle in many areas of the eastern United States. I mentioned the first one, milky spore. As I said before, it's used to provide a suppression, a long-term suppression of Japanese beetle. You can buy it, you could do it, you could put it out, and once you put it out, if you had grubs, it should reproduce on its own forever. However, again, it produces very little reduction. Again, 1 or 2, if it becomes well established, I don't think we could expect to reduce Japanese beetles more than 1 or 2% based on how milky spore works in the eastern US. So, you're going to buy it, you can put it out, and it'll spread on its own and might have some effect, but it's not going to solve the problem. So anyone can purchase this product and try to establish on their property. If successful, all you need to do is use it once. You don't use it every year. If it works, it'll reproduce and increase on its own. But there's 3 things that are part of the Japanese beetle biocontrol program here in Colorado. One is a kind of fungus that causes an infection of just Japanese beetle, and the other 2 are insects that attack and develop internally and kill Japanese beetles. These are all specific organisms that only attack Japanese beetle, were introduced and have had long term history of use in the eastern US without any impacts on native species. And we don't have an insect anything like the Japanese beetle that's native to Colorado to begin with. The one that I think is going to have the biggest effect is a kind of fungus disease. It's called ovovesicular papillae. Doesn't have a nice common name. It's not talked a lot about, but this is the one I think is going to have the biggest potential impact. It is a fungal infection that is Japanese beetle larvae pick up when they consume spores in the soil. And then what it does is it infects a certain organ in the Japanese beetle. And it's called the Malpighian tubule, which is essentially the kidney functions kind of like the kidney of an insect. It's very different than the kidney, but it has the same general functions. So it causes an infection of a specific organ in Japanese beetle. And this has an impact in terms of reducing viability. It produces stress. So the Malpighian tubules filter the waste from the blood. And again, if these are impacted, then there are health effects. So ovovesicular papillae, where it's been studied, has had the main observed effect in reduced survival of the larvae through the winter. They just are stressed. They've got their kidney, if their Malpighian tubules is not functioning well, they don't make it through winter well. If they do, they've got a shortened lifespan and they don't live as long or produce as many young in the adults. And where this has been used the most has been in Michigan, and where you can see over time, as this was introduced into golf courses, the infection rate of Japanese beetles went up, and concurrently the number of Japanese beetles over time has gone down. These all look nice, nice correlation that they're very likely related. I don't think I mentioned, but the figure that they had was survival of larvae. It decreases 75% if they are infected with ovovesicular papillae in Michigan. It may be even greater here since we have more stressful winters. Ovovesicular papillae was first introduced into Colorado in 2015. Had beetles that were infected from Michigan. They were provided dead, didn't have live ones, but the spores of this organism were within the dead insects, and these were then blended. There's a blending of Japanese beetles and then spread out on the lawn and in different ways. So there it is, being spread around. And it took, after that 2015 release of ovovesicular papillae, 2 years later, we were finding beetles that were infected. This is extraordinary. Usually it takes maybe a decade before you start to see evidence that something that was released is actually reproducing. But in 2 years, and also at another site in Pueblo, it was found to be infected after release. So to date, there have been a total of 12 places where ovovesicular papillae has been released, 2 in Boulder, 3 in Pueblo, and 7 in the Denver, West Arapahoe County area. And so far, there's been 3 places where it's been confirmed, established, but we don't have the data from last year in yet. Another thing that has been that controls Japanese beetle in some parts of the country to some degree is a kind of wasp called the spring Typhia vernalis. It is a wasp that goes into the soil, lays eggs that then hatch on the larvae of Japanese beetles in the spring. So the female digs in the soil, locates Japanese beetle grubs that are nearly full grown, lays an egg on the grub. The developing larva of the wasp then feeds on and kills that grub, and then the adult emerges the next year. This is an insect that comes out in May. The adults will need to feed on sugars, and so they feed on nectar and honeydew if it's available. And this is very critical for getting this wasp to work well. There has to be sugar sources for it, or it won't survive long. And if it doesn't survive long, it won't lay very many eggs and it won't kill very many larvae. So for instance, the sugar water is something that can be used dramatically. 2 years ago, I went to Kentucky to try to find a place where you can get some of this, and visited Dr. Dan Potter, who's the Japanese beetle guru. And he showed me we'd spray sugar water on the leaves, and then we would come back a little bit later, and there they'd be on the leaf. And then after that, we then brought them back and released them at the first site there in Boulder. But here's another picture. This shows after we released them, I would spray some sugar water, and it shows that they love, they feed on the sugar water. So they need sugars, and it can be a natural source from nectar or honeydew from insects. But for them to work, you have to have that nearby. So we picked sites where there were sources of nectar or honeydew. The 2020 site in Cherry Hills was a site that had peonies nearby. And that's, I don't know if you're aware, but peony buds will ooze a sweet material. And that is very heavily used by ants, and also a great food for Typhia. So this site here at a golf course had peonies. It also nearby had elm trees, and elm trees in the state, American elm, have European elm scale, and that gets honeydew. So we had honeydew nearby from elm trees, an insect, and we had peonies. So this was a pretty good site, and I hope we get establishment here in this Cherry Hills site. So far, this has been released. I've released it in Boulder and in Cherry Hills, and the Department of Agriculture has released it in Littleton. And then the last one is a fly, a tachinid fly, a parasitic fly, Estechita aldrichi, sometimes called the winsome fly. And what this does is search out adults and then glues eggs onto the adults. And we can see little white eggs near the head end of these adults. The eggs hatch and the larvae go in and kill the adult insect. So here again, a couple of pictures of the fly itself laying eggs and the adults with the eggs on it. So the egg hatches and the larvae then enters the beetle. Ultimately, it kills the beetle. The larva here will then leave and then pupate in the soil. The adult merges the following spring. So this one is one that comes out when the adult's out. So we're talking about late June, early July, when most of these are out. Now, one thing that is absolutely critical for this insect as well is pollen and nectar sources, particularly nectar sources. The adult flies feed on nectar to sustain themselves. And if those sources of nectar are not available, this will not survive well. So if you want to have this natural enemy do a good job on Japanese beetles, you need to have flowering plants that are providing nectar in late June and July. And the kind of plants that are good to support a tachinid fly are going to be ones that are little flowers, not, petunias, little flowers that they can access with their little mouth parts. So in this case, alyssum or dill or anything in the family Apiaceae, dill, fennel, cilantro, ammi, lots of things can provide the nectar sources for some of these natural enemies, including tachinid flies. But these need to be available in late June and in July for that fly to work well. There's two personal favorites that I really like. I plant both now, moon carrot and ammi, that just, oh gosh, there's so many natural enemies on those two plants. So this winsome fly so far has been released in 2 places in Boulder, 1 place in Pueblo, and 3 places in Denver and Littleton. And I hope we'll do more this next year as well of all of this. So there's a lot of stuff there. All of this, though, you can review on your own time. Not just, you can listen to this again, but we have resources on Japanese beetle that I think can help you with this complicated subject. Where you would find it is you go to the Colorado State Insect Information website, and if you're unaware of that, you can be linked to that. But this would be the home page of what that page looks like. If you go down midway into that page, there is something just Japanese beetle information. Hit the button that says resources, and then what comes up are several of the publications that I've already mentioned, a couple of publications that are just interesting research publications on the subject, and we can be adding more of these over time. One other thing that is in this Japanese beetle information website that you can download yourself is a publication 23 pages long on questions and answers about Japanese beetle in Colorado. I have tried to put in this every single question anybody's ever asked me about Japanese beetle, and it keeps getting added to, over time. But this is one of the publications you yourself can download, and I think it will answer a lot of your questions. So a lot of what I've been going over is found on that website. So that's it. I was quite a long talk here, but thanks for hanging in here. If we've got any questions, we can start doing that.
Thanks, Whitney. Yeah,
Okay.
I think there are quite a few questions. I'm going to let John and Carol kind of take the reins there to pitch those to you.
Thanks. So I'll as we go through the list, they're going to be roughly in order as they came in through the presentation. So we'll go back to general information about their arrival in Colorado. And the first question is whether the large infestations of Japanese beetle in our state are always associated where there is bluegrass lawn.
two different questions I get, but let me do the second one first. I think Japanese beetle is only going to be a problem where there's a large amount of irrigated turf grass. You live out in the country, there's not irrigated turf, it's not going to be a problem in the state. But that just is where they will amplify. They could be brought in anywhere, and how Japanese beetle is going to be brought into the state are various venues. The classic way is in roots of nursery stock, and that's probably how it got in. And we had several introductions in the state. Obviously, the one in Pueblo is different from the one that got started around Littleton and Cherry Hills several years ago. Who knows where the Boulder one got started from? That's probably a separate introduction. But they can also be moved in cars, and in many places in the country, they're being found near airports because they're getting on planes, and then often outbreaks are near airports. So that's how they spread. And again, now that we have large numbers here in Colorado, I mean, just people have to open their doors, their windows open, their cars, and we're going to be moving them around a lot more. But they'll only be bad in an area where there's a lot of irrigated turf grass.
Great. So the next question is, do grubs eat the roots of native grasses, specifically blue grama and buffalo grass?
I don't know. But if you aren't watering the heck out of your buffalo grass and blue grama, then they're not going to survive well because it's too dry. So if you're using low water use grasses, whether, I mean, that's, I can't tell you if they would survive on them, you know, if their conditions were optimum, but if you're not watering very much, no, they're not going to live there. I mean, you're not going to see them on buffalo grass or blue grama grass in the native prairie because it's too dry.
All right, thanks. We were talking, you mentioned earlier about mowing your flowering weeds before applying any insecticides, specifically imidacloprid, that could be harmful to pollinators. Is there any amount of time that you should allow to elapse for grass recovery between when you're mowing and applying those pesticides?
Grass recovery? I think it should probably be applied very shortly after you mow, because that will allow more of it to get into the root system, to sift down to the base of the plant. If you have a lot of vegetation on the top and you're applying an insecticide that you're trying to use to control an insect in the soil, a lot of it would be intercepted if you had a lot of foliage. So mowing will also help improve getting the insecticide to the grubs. So not only, so it has multiple values on top of, eliminating any flowering plants that you have for the pollinator risk. Yeah, mow beforehand. That's a good idea, and then water in after that. It's a good idea to water in as soon as after you've applied it, because again, you're trying to get to something that might be an inch in the soil. It's not sitting up on the top, and the systemic insecticides don't move systemically down. You have to move the insecticide to where they are.
So I know there's a wide host range for the Japanese beetle, but the question is, do they feed on any native plants?
I don't know. That's to be determined. I mean, they certainly do in the East. Yeah, a lot of their hosts are native plants, elms, and are a really favored plant. I guess the crab apples wouldn't be native, but I don't know. I mean, in terms of native Colorado plants, we don't know yet. I mean, it's too new. It would be. I guess I've seen some. I mean, I think the only native plant I've seen been feeding on pretty well is evening primrose, but lots of stuff feeds on that. I don't know. That's something to be determined. It's a new game here. We're the only we're the only state, we're the only Western state that has ever had Japanese beetle in a real way. Other states are going to get it. Portland, Oregon has a problem, and they think they're going to get rid of it, but they're not. But yeah, I mean, these are things that we should be looking at. And then in 2 or 3 years, we could have lists of native plants that resist Japanese beetle or native plants that don't. But that's all to be determined. That's what I hope master gardeners can help with. Well, anybody who's interested in this. Yeah, it's a new thing.
Thanks. Do you know if Japanese beetle is altitude specific? That is there a height at which it's unlikely to be able to survive?
I don't think altitude has. I mean, Denver is higher altitude than any place east of the Mississippi. So in terms of altitude, I would think I think it has far more to do with soil moisture, maybe growing day length. I mean, at some point, if it gets too high, then we're going to have shorter growing seasons. However, and maybe it'll act differently at a higher elevation. So in Japan, where it's native, Japanese beetle normally has 1 generation a year. In northern Japan, it takes 2 years for it to develop. So, maybe in high altitude Colorado where everything was great, it might take 2 years for the insect to develop instead of 1 year. But altitude by itself would not have an impact. It'd be other things like, again, soil moisture and growing day length and the like.
Are you finding that some plants that weren't damaged in the past, including some of the roses, are now being eaten by Japanese beetles?
No, I mean, it hasn't been looked at over time enough to see those. I mean, they're just these have been snapshots in time, but over 3 years, plants that weren't getting chewed in any of those 3 years, so I don't think it would change as long as there's alternate things around that they are going to feed on. I mean, if there's nothing available except something that's low preference, then maybe you'll see more feeding on it but I don't think it's going to change because they become evolved to feed on it. I think they're going for whatever's the most desirable thing in the neighborhood in the year.
All right, this next one is about trapping. If everybody in town put out a trap, would that help? For example, I could catch my neighbor's beetles and they could catch mine.
Yeah, maybe. How are you going to do that? And how would you prove it? Because at some point, not everybody's going to be doing it. The next town. I don't know. I don't know how you would prove that you're getting much effect on that. I don't. The one place where trapping was part of a program, but was when Japanese beetle got into Palisade. I didn't even talk about that, but Japanese beetle did get into Palisade in western Colorado. That's a small town, and it's on the western half of the state, and as a result, it had a huge potential impact on the agricultural markets that the western Colorado had. So there was a big effort made to try to eradicate it from the little town of Palisade, and that involved treating everybody's lawns, A lot of people did the dry down in July, and there was a lot of traps. And together, all those things did eliminate Japanese beetle from Palisade. So in that case, it helped, but there weren't a lot of Japanese beetles in the town to begin with. I mean, they get more. The total number of beetles caught in Palisade, you might get in one trap in Denver now. It's one person's backyard. So I don't know. I don't know how you'd prove it, and it'd be hugely expensive, and it'd be hard to get everybody on board. But I wouldn't bet the ranch on it.
So you had a cheat sheet that you were referring to. Is there a link that we can post to that?
That's in that Japanese beetle area in the website. So
Okay.
so one of the things if you go to the Japanese beetle section, it has controls of larvae and controls of adults. It's also got questions and answers, got the fact sheet, a couple other things. Yeah, that's all in there.
Those links are also in the chat box for those of you who asked for them. And the list of roses that Dr. Cranshaw mentioned will be posted with the recording of this webinar.
Yeah. Yeah, I should
sorry.
put that up on the site. Okay. Yeah.
The next one is about the ovovesicula fungus. And do you think that it's likely to spread on its own?
It does. Well, it does elsewhere. So yeah, I think it will. The way it spreads is some of the adult beetles are not killed, but they are infected, and they do disperse, and then they die, and then there's spores. What I hope we can do is just track this. I mean, because one of the wonderful things, from a research point of view, but one of the wonderful things that Colorado has for this whole biocontrol issue is that those organisms would not get to Colorado without people moving them. Whereas in the East, I mean, they may be moving in from the next town or whatever. So we have purposely been putting the biocontrol organisms at least 2 miles apart from any release site, trying to keep them at least 2 miles apart, so that then we can now track to see how it spreads. So we'll know the answer to that. I mean, nobody's had a good lab to do this, but we have it now set up. We've got places where they're introduced, and we can now start trapping from various distances of the release points and get a good idea on how they're spreading. Have to get money to pay for all this, but I mean, we got the lab. It's set up now to answer exactly those kind of questions, and then those kinds of questions will be used for Portland and everybody else in the future who gets Japanese beetle up in Idaho, near Boise. I mean, there's similar areas that are going to have to deal with Japanese beetle like Eastern Colorado is having to deal with it now.
And there was a question on the Typhia. The Typhia don't tend the honeydew producing insects?
They don't tend it. No, they just take the honeydew. So unlike ants that might be tending aphids for honeydew, no, they're just looking for sugars. And again, for the Typhia wasp, I mean, there's not a lot of sugars around that are available for them in May when they're out and about. So mid-May, I mean, we have flowers, but we don't have the kind of readily available sugar. If we had more aphid, we want as good aphid problems in May to produce lots of honeydew. That would support them. But that extrafloral nectar that comes off the peonies is one that is reliable and evidently very heavily used by Typhia wasps if they're in the area.
All right, thanks. Speaking of Typhia and other biocontrols, is there a possibility that these or other non-native insects will become a problem to native insects?
So I mean, that's obviously the huge issue that you have to deal with before you do any of these kind of programs. And that's why has to be done with vetting and supervision of the federal agencies. But these organisms that are in this program are ones that have been vetted. They have not ever been found to impact another species of insect in North America. They are specific. If there had been a problem, if they were getting a non-native, then they wouldn't be in. But they're not something that if they run out of Japanese beetles, they're going to go after something else. If they run out of Japanese beetles, they're going to die. They don't change. So again, these have the things that are being introduced into Colorado had decades, nearly a century, no, not quite, but several decades of experience in eastern United States, at least since the 40s and 50s.
So there's a question that of the ovovesicula release sites in Boulder, there were 2 sites. Believing one of them was the Flatiron Golf Course. Where is the second?
CU campus.
CU campus.
Yeah, CU campus. Yeah. Trying to find, so there can be others. One of the big things for finding a site for ovovesicula, each one of these, there needs to be certain conditions to make it a good release site. So for ovovesicula papillae, you need to have a site where where there's grubs. And there's, I've heard of places like in Boulder, say the tea house. I mean, they complain about the grubs, the beetles there, but nobody has found where the grubs are that turn into those beetles. If somebody would find where the grubs are, that might be a good release site for ovovesicula there. But that's what needs to be figured out. So there was one place in CU campus where they had found consistently good grub numbers. So that's why it was put there. The other sites, again, you need flowers. If you don't have a diverse environment with sugar sources that are going to support the Typhia wasp or the right kind of nectar producing flowers to support Istocheta, the winsome fly, why waste your time? They're not going to do well there. They need to be a site that's got a lot of beetles and are a diverse habitat that can support these natural entities. Or they won't perform well. They won't survive well.
Thanks. We've had a few questions that are particular about plant types other than roses that are resistant to Japanese beetles or that do well for Japanese beetles. I'm happy to ask you some specific questions, but I wonder if you might know of any resources that just list plants that are resistant to Japanese beetles or even cultivars among crab apples or fruit trees, for example.
There is with crab apples, because that's been worked up quite a bit in the East. And I mentioned lindens. There's some good stuff with different lindens, because some lindens are extremely susceptible and some are not. But other than that, no. And even the lists that have been made, these are done by people who live in Kentucky and Ohio, and that's where all the work has been done. And the plants that we are growing aren't the plants that they grow. So we are going to have to generate all this information ourselves. I mean, it's a whole new thing. I mean, Japanese beetle is going to act differently here than it's acted anywhere where it's been before. So no, there isn't yet, but there can be. Again, if we, make these observations and collectively, come up with these lists. But what we need are areas where there's a lot of Japanese beetles, and you can see what they're feeding on and what they're not. There's not a lot of great places to do that, but some of the botanic gardens, Denver Botanic Garden, you can do it now. You can see what they're feeding on and not. Maybe Hudson Gardens, that's a big area where there's lots of different plants. But a lot of places it hasn't gotten there in high numbers yet, or there's just not a lot of different plants to compare it to. Sorry. don't have the answers yet.
Thanks. So the question is, how concerned should people be about plants and turf grass moving around the state?
So moving turf grass sod, that is a concern. I don't think turf grass farms are likely to be a big area for Japanese beetle, but that is a concern, and I think the Colorado Department of Agriculture does inspect that if there are treatments needed to move sod from areas where Japanese beetle is to areas where it doesn't exist anymore, or it doesn't exist yet. It could be. If it's going to be carried on other plants, it would be is on the roots of container stock that we're moving between city lines and the like. I think some of it will be, people will be moving it, but again, in eastern Colorado, I think at this point in time, they fly around dozens of miles. I think they could, and in addition, again, they get into cars. I think people are just going to be spreading them. That's going to be the big way they're going to be spreading now. And there's not. I think what needs to be done. I think there needs to be extra effort to make sure it doesn't get on the west slope, but just people driving up and down eastern Colorado. It's all going to be. They're already there. I'm pretty sure. We just haven't seen them at a level where it attracts attention. There has to be, quite a few for several years before people even know if they're there, and then it's too late.
Thanks. We've got a management question from some folks have noticed how much Japanese beetles enjoy fruit trees. And the question is regarding commercial orchards. Do you know, for orchards that are experiencing Japanese beetle infestation, how do they typically deal with that issue? What about vineyards, for example?
Well, most places where there's vineyards, there's not a lot of, at least in Colorado, there's not a lot of irrigated turf grass. So there's not a lot of Japanese beetles. So most people avoid, most agricultural areas in our part of the country avoid it. Elsewhere, Japanese beetles can be developing in a pasture because it gets 40 inches of rain, and the Japanese beetles just do fine in the pasture, but that's not going to happen here in Colorado. So, it's more of an urban. It's going to be more of an urban kind of problem. So, urban grapes, it's a problem. Urban fruit trees is a problem, but less so out in the country. It's a defoliator, so it chews leaves, and in some lots of other things can be chewing on leaves of fruit trees, and there's sprays that can kill them. But it's just not a big issue in rural areas in Colorado because we don't have all the irrigated turf grass where the crops are being grown.
Thank you. We have a question about genetic modification of plants with the BTV toxin enzyme. Is there research being done for that, for control of Japanese beetle?
I doubt it. And I don't know if it'd be a good idea for a couple of reasons. But one of the reasons is just if you, and we saw this with putting BT in some crops, different kinds of BT in other crops, is that's a way, if you use it a lot in plants, then the insects are much more likely to get resistant to that toxin. Whereas if you're using it, spot sprays here and there, you're having much less selective pressure for the insects to develop resistance to it. So I can't imagine anybody's really working on that, on the kinds of plants they're looking at. Not right now. Plus, there's market concerns with genetically modifying in the first place. So no, I don't see that as something we'll be seeing for this insect.
All right, thank you. The next question is about data from a resident of Pueblo. Is there a way for the public to get access to information about where Japanese beetles are present, for example, by street grid even? And also, is there a way to learn where natural enemies have been introduced?
Publication, just a summary of all the releases of natural enemies. I should add that to the insect information website, and I'll try to do that. I want to check one thing with the Colorado Department of Ag to see what they've done. But in Pueblo, for Pueblo, the original releases were at the Pueblo Zoo and the golf course adjacent to that, and then also at the mineral park I can't remember the name, but a mineral park. So those are the two areas in Pueblo.
Thanks. The question is this the same insect that affects soybeans in the Midwest?
It does. It chews on soybeans. It's not a huge soybean pest, but it's one of several beetles. I don't think it's the main beetle. There's bean leaf beetle. There's Mexican bean beetle. Japanese beetle too feeds on it, but it's not a huge pest of soybeans. But they'll chew on soybean leaves.
Thanks. We had a few folks ask if you had ever heard of dogs being interested in digging up white grubs in addition to skunks and raccoons.
No, I haven't, but I bet there's some dogs that would be trained to do that. Although, I mean, to get the grubs, the skunks and raccoons dig up a lot. I mean, they make a mess. So I don't know if I'd want to train a dog to dig for the grubs in my lawn. It'd probably ruin the lawn, do a lot more damage than the grubs would do. So the big thing is about mentioning the varmints that go and chew them is that's often the first heads up people have that they have grubs in the lawn. The lawn they don't notice anything because there's not enough of them to do damage, but all of a sudden, what's going on? Something just tore up my front yard. You've got grubs. That's almost, I can't think of anything else would make them tear up a lawn like that. You got some kind of grub, and now it'd be Japanese beetle if you didn't have it before.
Thanks. Is it true that the beetles dislike clover lawns for laying their eggs? In other words, will adding clover to turf reduce larval infestation?
I don't know. I can't. That's been looked at. I'll try to look. That'd be a question I should put in the questions and answers. I don't want to say, but I know there's been some work on that, and there's been a statement. I can't remember who. I'll have to look that up. Yeah, it helps. Yes, it definitely helps. You would have less damage, but I have to find the source on that.
All right, thanks. What is the best time to let soil go dry in order to combat egg laying and the susceptible to drying instars of grubs?
I'd say the first half of July, probably the best time. And it doesn't need to be, just need to, and so if you can water deeply earlier, so you've got deeper rooting plants, then you can cut back a little on the water during this other time so that you get more of the soil drying. But most of the eggs are going to be laid in the first half of July. I mean, there'll be some be laid later than that, but most of the action is going to be probably the last week in June, and in particular, the first 2, maybe 3 weeks in July, at least in Denver.
Great. Do you plan, or do you know of any more plans for release sites for ovovesicula in 2021?
It depends on, I mean, we will be looking at other sites, looking for new sites, again, trying to keep them separated from each other so they can be tracked. It depends. Michigan State University has been providing the material. They got a big grant to do this, to spread the ovovesicula to areas around the United States, big USDA grant. And they will provide more this year. Last year, we only had enough for 2 sites that they got us. But last year was a screwed up year. I mean, nobody could go to work. So I'm happy we got anything last year. This year, maybe we can do it even better. Maybe now that I'm retired, I'll go to Michigan and collect them myself. So then we could do it, be fun.
Speaking of biological controls, how soon will we know if any of these biologicals are effective or how effective they are?
Well, often it takes several years before you even know they have established, and then you see if if they're thriving. I think again with the ovovesicula papilli, the fact that it was established within 2 years after being released is very promising. And then if these work, then you'll see a reduction over time. And so I guess I should have, in fact, I think I forgot to put that in I had a slide on that to talk about. So what it would mean, a successful biological control program for Japanese beetle, a really successful one, if everything works, would mean that in 10 years, maybe 12 years, instead of having 10 Japanese beetles sitting on your rows, you'd only have 3. I mean, it's not going to get rid of it but if we can get a reduction, take 2/3, 3/4, that would be a big success. But it's not going away. These don't get rid of it. Japanese beetles here to stay.
Okay. We are closing in on our 8 o'clock deadline here to round out the webinar. So I picked one final question that I think kind of summarizes where a lot of people are going here, which is, what's your number one go-to solution? Do you have a number one solution? The choices are really numerous. And so do you advocate over one stage versus another? We get this is complicated, but what do you think?
Well, first of all, I think most people just care about the adults. So forget the larval stuff. I mean, it's going to help a little bit, but that's if you're going to do only one thing, go for the adults. I think if you have a plant that has flowers, is not attracted to pollinators, then there are some insecticides that will give you quite good control. Maybe 2-3 applications a year and give you good control. But if you have flowers, then it's hand picking and that new BT. That's it. I mean, those are the only things you can use if pollinators are visiting those plants. And maybe we'll have to start finding plants that don't have Japanese beetle. That's going to be, we don't have those lists, but if we had those lists, then, we can't get lists that we got from the East. We have to make Colorado lists because we got different plants. That's a long-term thing. But,
Excellent. And I made a few notes that I think there's an opportunity for us to work with the Colorado Master Gardeners, particularly across the Eastern Plains and the Front Range, to do some kind of survey and collect some data this year. I think that's a great opportunity. Okay, so I lied. There's going to be one more question. What is the species of jackalope on the wall behind you?
It's a pair. It's a mating pair, and they're
great, because inquiring minds have wanted to know.
It's a jack of mule deer. There's very few true jackalopes. So that's another talk. There's at least 8 species of jackalopes, and based on postcards that I've got. So that one's got That's got mule deer horns, so that's not a true jackalope. So
We'll have to plan for another webinar, Dr. Cranshaw.
yeah.
For those of you who don't know, Whitney, most people know who you are. You have quite a reach across the country, across the world, honestly. And we're so lucky that you were able to share your insights on the Japanese beetle with us. And for those of you who aren't aware, Dr. Cranshaw is a professor emeritus now, which essentially means that he's formally retired, but gets to do all the things he wants to do now in academia. And thankfully, Japanese beetles falls within that, as well as some master gardener training, and hemp entomology too is another one of your passions. And so we'll continue to engage Dr. Cranshaw as often as he'll allow it. And we appreciate everybody, your thoughtful questions tonight, and the work of my colleagues to help manage those questions as they came in. Any parting words? Anybody? John, Carol, Whitney?
No, I think.
We'll leave it there. Thanks, everybody.
Okay. Good
We'll
night.
get this posted on the CSU cohorts blog. So if you missed anything, you can go back and watch that again.
Okay.
Thanks. Happy gardening.